Great, so now we're looking at plasticity and functional recovery. Plasticity and functional recovery can be asked about as one topic in a 60-mark question. They could be asked about separately. So please make sure you can differentiate between the two, but also remember you can use both together if you're talking about them in an exam. Plasticity is our brain's ability to change and adapt as a result of experience. The brain adapts over time and our brain can change. Think about it as being plastic as being literally like plasticine. Our brain is able to change shape and kind of move. There are different things that can affect the structure of the nerves in our brain and how they work, including life experience, video games, and meditation. And on the PowerPoint, there's a link there to look at in terms of plasticity. You've also got this video in terms of what neuroplasticity is. As it says on my computer, my children have been on. You could try watching it on normal YouTube as opposed to YouTube Kids. In terms of plasticity, during infancy, the brain grows a lot and it's in a state of continual change. If we use parts of our brain, more nerves will grow in that area. If we don't use parts of the brain, nerves will not grow in that area. So what has become clear from research is organization in terms of the nerves in our brain can be changed from a result of experience, and there are different types of experience that can do this. And as said before, there's some research on video games and there's some research on meditation as well as life experience. So plasticity as a result of life experience, the more we use our brain, the better it is, the stronger the nerve connections are. The less we use our brain, the less good nerve connections are. There's some research on this. Boyk taught some older people how to juggle, and they found an increase in grey matter in the visual cortex. So they were using their visual cortex more to visualize where the balls were when they were juggling, and then there was a decline in this area when they stopped that task. So things we do in our life can make different parts of our brain be used more, and that can change the neural connections in our brain. Our brain is plastic. It can change based on how we use it. Playing video games can also change the structure of our brain, and there's lots of research on that. The areas of our brain that we use for video games can be increased with excessive or increased use, increased playing of video games. Meditation can also affect our brain structure and can have more long-term effects than life experience and video games, and there's research on that as well. So in terms of AO1, you can mention life experience, meditation, or video games as examples of plasticity, things that can change the structure of our brain. Plasticity tends to be positive, but can also be negative. For example, drug use can reduce cognitive functioning, and disorders like dementia is an example of negative plasticity. In terms of evaluating plasticity, there's research using animals. So you can use Kemperman's study where rats that had kind of fancy mazes to navigate had increased neural capabilities as opposed to rats that lived in boring cages. So it's supporting environmental life experience in terms of plasticity, but obviously using animals, so you can evaluate that. There's also some really good research on Maguire. She did some research on taxi drivers and found that taxi drivers had increased activity in their hippocampus due to the nature of their job. The London taxi drivers, you have to learn all the roads in London and learn them off by heart. You aren't allowed to use sat-nav. So the Maguire's research is really helpful in terms of plasticity. It's some really good research. So there's some detail here on Maguire's study and how she did this. If you click on the picture in the PowerPoint, it takes you to a video of the knowledge, what that is, what taxi drivers have to learn. And if you click on this picture, it takes to a link to a video of Maguire's actual research. Maguire's research can be evaluated because it had a control group, because it used MRI scans, so it's scientific and objective, and it's a real-world phenomenon. However, it's a small sample. You can argue that it lacks population validity. You can't generalise, and you cannot establish causation because Maguire only found a correlation. In terms of evaluating plasticity in general, there are some points there that you can elaborate on for some positive AO3 points. You could also talk about negative plasticity, and you could also talk about the fact that plasticity changes with age. So that is plasticity. Functional recovery is damage to the brain that involves a change in brain activity following kind of a sudden injury or damage, so a stroke or an accident. Functional recovery is an example of neuroplasticity. It's a specific example of neuroplasticity. In terms of functional recovery, your brain is able to rewire and reorganize itself by forming new synapses and forming new neural pathways. This is called neuronal unmasking. So then there's some research to suggest that we have spare nerves that we don't normally use in our brain. And if we have an accident or an injury, we can unmask, we can kind of uncover these nerves and kind of use them to compensate for the damage that has occurred. There are also some structural changes that happen during functional recovery. So you've got axon sprouting, you've got reformation of blood vessels, and you've got recruitment of homogeneous areas. So using the parts of the brain on the opposite hemisphere to compensate for the areas that are damaged in the damaged hemisphere. Just to point out, in an exam, if you're asked about plasticity, you can include functional recovery in your answer. However, if you're asked about functional recovery, do not talk about plasticity in general. Functional recovery is an example of plasticity. Research suggests that if brain cells are damaged in a trauma, the brain can rewire itself, as we've said. There's some research by Wall on neuronal unmasking, which looks at the spare nerves that we tend to have in our brain. There is evidence to suggest that the more time you're in education, the more of these dormant synapses you have, the more ability you have to kind of compensate for damage. There's also research on stem cells, where kind of stem cells or blank cells have been implanted into the brain to replace damaged cells. And these stem cells are then kind of changed or modified by the brain to compensate for the damage. So that is some kind of up-to-date research on functional recovery. There's also some animal research. So Tajiri looked at rats who'd had brain damage and looked at stem cell treatment in rats. Schneider looked at the effect of educational attainment and functional recovery. So they found a positive relationship between education and functional recovery, but there's no causation because it's a correlation. Tajiri's rats, again, sorry, just there. And remember, if you're using any animal research for evaluation, make sure that you qualify that in your essay. Echolocation is an example of plasticity in brains. There's a link to a video from the picture at the top, and you can use the example of echolocation when you're talking about plasticity or functional recovery. You can also talk about age differences in functional recovery. Plasticity reduces with age. Our brain is more plastic the younger we are. Think about it as Play-Doh that's just come out of a tub. It's nice and squishy and it can change. Think about an old brain as old Play-Doh. If you've left it out for too long, it becomes hard and you cannot change it anymore. So your brain is more plastic the younger you are. However, you do have some plasticity in adults, and in older adults, it's just not as much as in childhood. This is important if you get an exam on plasticity, and in the STEM exam question, and in the stem of the question, it refers to the age of the patient. A younger person will have a more plastic brain. Schneider's research again. There is a case study of Gabby Gifford, who was shot in the head and suffered lots of brain damage. There's a link to the video. This demonstrates functional recovery. It also helps you to revise lateralization, so it's worth a look. And that is a potential 16-mark question on just plasticity. You can mention functional recovery in that question. Use Maguire's research as your research on plasticity. There is an essay question in the booklet. This is just some guidance if you are doing that. And just for research, extra research, you've got a video linked on the original PowerPoint on the girl with half a brain and the boy with no brain.